Assalamu alaikum to you all. Welcome to our lab number 5. Lab number 5 is about queues. And actually it's going to be a very short lab because there's only one task you have to do this time, not 3 tasks as we used to have. So it's going to be a very short lab. As usual, the objective of the lab is to learn how to implement queues and also how to use queues. Okay. In terms of examples, you are given the 2 examples that we saw in the lecture. Basically implementation of a queue using array, where we treat array as a circular array, and implementation of a queue using linked list, using the Java's linked list. Okay. In each case, you are given a test class. So there is a test ArrayQ, which allows you to test the methods of queue, and there's a similar method to allow you to test LLQ. Okay, so LLQ and test LLQ. These are the examples. If you download the lab, you will see them in lab 5 project, and as usual there is a document which explains what the lab is about and what the tasks are there for you to do. So I have already opened both the document and the NetBeans project. Okay. So in the NetBeans project, you will see the 4 examples. There is ArrayQ, test ArrayQ. Okay, LLQ, test LLQ. Of course, you're going to see DLL, the Java in the project, because you're going to use it to do the task that you are given to do. Okay, I have implemented for you a queue using LL stack, and therefore, like I did in the stack, you're going to be required to write your own queue, but using the DLL class. Okay, but first let's go through the examples. The ArrayQ, there is nothing to explain because we have seen all the methods. Basically, you need 2 variables, first and last, to keep track of the position of the first element and the last element. And we use an array of objects to store the data. We explain the 2 constructors. One will accept an input in terms of size, and one of them will use the default size of 100 elements. Okay, and then we saw the enqueue and dequeue methods. So enqueue will normally put in the next location. This is the typical case. Okay, but there are cases where the list is empty, so, and also where the last is at the end of the queue, so you have to take care of that. And the same thing for the dequeue. So I don't have to repeat the explanation of the method, you already know them. Perhaps the one that is interesting is how do we test this ArrayQ. Okay, so for testing it, you have to create an object of ArrayQ. This time, please note that it is not a generic class, so you don't need to give any type. Just create an object of the class. So suppose you create a queue of size 5, then it will allow you to enqueue elements and dequeue as usual. Okay, so enqueue an element, dequeue an element, get the front element, print the queue, clear the queue, and quit. Okay. So, and there is really nothing in the cases. For enqueue, you just read an element from the user and call the enqueue method. Okay, and similarly for the dequeue, just call dequeue, get the element and print it. Since dequeue is not a void method, you have to call it as part of print statement. Okay, and similarly for get first. Okay, and then there is print all, there is a clear. Let us quickly run this program and see if it works as expected. Just say run file. So let's say NQ5. Okay, if you print the Q at the moment, which is option 4, we shall see the Q contain 5. Okay, option 1 again to NQ, let's say 10. If you print the Q option 4, you will see 5, 10. NQ 15 and print the Q option 4, you will see 5, 10, 15. Now if you dequeue, what do you think will be printed? Obviously the front element. This is the reverse of stack. Okay, so let's see. If you say option 2 to dequeue, it say element 5 has been removed. So if you print the Q, you will see that indeed 5 has been removed. Now the new front element is 10, and so on and so forth. So the methods of this array implementation are working. You can, just to make sure the circular nature of the array actually works, let us, so far we have added 3 elements. So if we add 2 more, we will have reached the end of the queue. Okay, so element number 6 that we're going to add will definitely be stored in position 0. So let us try and see whether that will work. Let's add 3 more elements and see, will the queue still work? Okay, because now there are 2, so normally there should be 3 more spaces for us to add elements. There will be 2 on the right and 1 on the left where we have deleted the 5. Okay, so let us see. In Q20 and Q25 and in Q30, and now print the Q. So option 4, you see all the 5 elements exist, which means actually the Q indeed cycle back and put the 30 in position 0. Although when we do the printing will not show that actually, because remember how we are doing the printing. We start from first to the end of the array, then we start from 0 to last. Okay, so circular array implementation of Q is working as expected. Okay, let's look at the other more natural example, the LLQ. Okay, the LLQ is more easier and more natural, where you use linked lists. So we create a linked list to implement a queue, so that to enqueue we just need to call add, and to the queue we just need to call remove first. Okay, to get the first element we just call get first, and so on and so forth. So this is also working properly. I'm sure you can test it. I'll just show you the code. I don't have to run it. I'm sure you can run it to see if it works. This is the test LLQ. It's providing the same methods. The only difference is the way you create the queue. This time it is a generic class. So to create the object, you have to say LLQ of integer. Q equal to new LLQ of integer. Okay, and the options are more or less the same, like you call test ArrayQ. You just need to read the element from the user and call the enqueue method. Okay, so no other change actually, just in the way you create the class, an object of the class is slightly different than the way you create an object of test ArrayQ, because this one is not a generic class. Okay, so if you test it, you will see that it is also working properly. Now, what is the task you are supposed to do? Very easy, actually almost the same like you did with the stack, the first task of stack. Okay, It says you are given dll.java that implement generic linked lists as we saw in lab 3. A. Use this class to implement a queue called DLLQ. Okay, so very similar to DLL stack that represent a queue or a queue for processing any type of data type. So it has to be generic. Okay, generic queue. Right, so what do you have to do? Very simple. Just come to your LLQ here, copy it and paste it and refactor it as DLLQ. Okay, so the name of the new class you're going to have is DLLQ. Please don't override this one. Don't make the changes in this one. Make a copy. Okay, so the copy will be called DLLQ. Here, we're going to delete this import because we don't want to use the Java's linked list to implement the queue. I have already done that for you. We want to implement a queue using DLL. So you have to replace this list to be an object of DLL. Okay, so you're going to create an object of DLL and you're going to use that to implement the methods of queue. Since the method of lists, the method of linked lists are slightly different in names to the method of DLL, you have to go through this method and make the necessary changes. For example, there is no add method in DLL. You will have to call what? Add to tell. Okay. Some of the method may be the same because I think the get first is the same for both DLL and linked list. So no change needed here. But there is no remove first in DLL. So you have to call the appropriate method. Okay. So that's the idea. It's very similar to what you did in DLL stack. So create a DLL queue using DLL. This is task number A. Now once you do that, the rest of the task actually is just to test this your DLL. You need to test it first to handle double values. So write a test class called test double Q that uses DLLQ to allow the user to perform similar operations to test LLQ, but using double values, okay, double data objects. So again, it's similar to what you did with stack. The idea here is you need to refactor this test LLQ. Okay, test LLQ. Okay, so you have to copy it and paste and save as test double Q. This is the name. Okay, so once you have that, now you have to make two changes. Change number one is this should not be LLQ. In this test, we are trying to test your own queue, the one you did in task A. So that one is called DLLQ. Therefore, you have to create an object of DLLQ. The second change is that it should manage double values, not integer values. So you have to change this to double. Okay, so once you do that, you just need to go through the class and make the necessary changes to make the program work. Basically, you have to, for example, change here because we are dealing with double values. You have to say reader.next double, not reader.next int. Okay, and so on. So make sure you test your DLLQ to manage double values. This is the idea of task number B. And the last task, as usual, we want to see if your queue can handle student objects. So again, you have to refactor your test double queue, call it test student queue, and make the necessary changes to make sure the queue can handle student objects. This This is basically what you are supposed to do in this lab. Very simple. Just one task. Create a queue using DLL. B, test it with double values. And C, test it with student objects. That is it. And that is the end of my explanation. Thank you very much.